Good afternoon, everyone. I just realized that I did a really bad job of explaining measuring reflection and refraction when we're doing our experiment with the light boxes. So I thought I'd just do it again, and then you can watch this over and over again and get a feel for it if you need to, or just once. But I need to clean up that mess. It wasn't my finest hour, I reckon. Anyway, here we go. So the first thing we need to understand is this idea of the normal. So normal is this line, imaginary line. So I've drawn a line at 90 degrees to this surface. Yeah. So this is the incident ray. So the light coming in, a wave of light coming in, and it strikes the surface there. So that's the angle of incidence. That's the incoming ray. You can measure that. And then the angle of reflection, is the outgoing ray. And as you can see from that diagram, they're basically the same size. This one bends away from the normal. Okay, that's the other thing we have to get our heads around. The other idea of this angle of incidence and angle of refraction was important. So here again is my incident ray. There's one normal, drawn at 90 degrees to the surface. Say some prism or something. There's the incoming incident ray. So there's the angle of incidence, the difference between that ray and the normal. And then it refracts as it comes through that. It gets bent, if you like. I should say denser. Someone's done a really poor job of that one. This is a denser material than the air out here, and so it bends more. And the angle of refraction is this difference here. As you can see, that refracting line bends back towards the normal. That's an important difference. Okay, bending back towards the normal. And there's another little one I've just stolen off style. It's showing us that reflection. It's another little activity we'll get to do this week where we can play around with this, but you can see how that's the same angle. So whatever that angle is it hits there, it reflects at the same angle. And that's just worth knowing. Whereas as it refracts, of course, away from the normal, as it refracts, it will bend back towards the normal. And that's sort of shown that again. I sort of took a few different images to give that same idea. So here's a light beam coming in, a ray of light. It reflects the same angle, and we can see that's 30 degrees. But because this material is different to that material, it doesn't refract at 30 degrees. It refracts a bit less, about 22 or something there, back towards the normal. Yeah. And again, that's something we can play with on one of our style sheets, which is rather handy. So the takeaways, the important bits and pieces that you need to know from all this stuff. One, the normal is just a line drawn at 90 degrees to the surface to measure the other angles from or against. Reflection, the direction the light beam takes when it bounces off the surface. The light beam bends away from the normal, and it'll be the same angle as the incoming light, the incident ray. Refraction, the direction the light beam takes when it passes through a surface. So the light beam bends back toward the normal. The angle of incidence, the angle formed at the point of incidence between the incident ray and the normal, is called this angle of incidence. And then the really important thing for us is that different substances will cause the light wave to refract more than others. So light bends when it comes from the air into water, or through that prism, or through glass, plastic. All those things have a different refractive index, so they refract more or less, and different to air. So you get that bending. And hopefully that makes some sense of the mess I made before camp when we were doing this with the light boxes. And for those who need to watch again, you can always can. Cheers. Thank you. Stop.